Hi, hi, this is Alex, and I will go to the third question or the first question in this paper. So just like previously, I will using whiteboard in my iPad. So just wait a second, let me open my whiteboard. So let's go over the problem here. The question is like that. A golfer hit a ball at the speed of 30 meters per second in which is angle at the 50 degree, and the ball landed on the building which is 11.5 meter. And with the question is provided here, it said it shows that the ball reached the highest point, and from the highest point falling to the building. So in this problem, I will divide this question into two parts, which is from the baseline to the highest point, from the highest point to the building. It's mainly because when the velocity in the highest point, the vertical speed would be zero, which is Vy2 equal to zero. And because of there's no other forces function on this ball, so it is a uniformly acceleration motion in vertical direction, and then there's no acceleration in the horizontal line. So in the horizontal, you'll easily get the xvxt, and then in the vertical line, the time equal to the change of the velocity, which is the 0 minus vy, and divided by the acceleration, but the acceleration is minus g because it's different direction, opposite direction of the velocity. Yeah, from there we can get the each t here. From this one is also we can get the speed here, and that is vy dash, and divided by g equal to t2. So the time spent on here is divided by into two parts, which is T1 here and T2 here. So that's my analysis, and let's go to the problem and solve it. So the question gives us the initial speed as a 30 meter per second. From the 30 meter per second and the angle is given, we can easily get the speed in the horizontal line and the vertical line. Let's say the Vx equal to V naught times Vx. So this is a cosine, and Vy equal to V naught times sine 50. From here, we can get information as the horizontal speed is 30 times 0.64, which is 19.2 meter per second, and Vy is 30 times 0.77, which is 23.1. And then we go to the first motion from the lowest, which is from the lowest part to the highest part here. So as there are no other forces in vertical lane other than gravity, the speed would say that 0 minus Vy squared equal to minus 2gh. Since the g is a opposite direction of the velocity, I put the minus 2g. So that leads to h as the 2g divided by the Vy square. So we plug in the number we get, so we can easily get the Vy, H as 23.1 square and 2.92 times 9.8. So that leads to H as 27 meter. And then in this scenario, because the T1 is the V1 Vy divided by 3, because this is an initial change is the Vy, and initial change is the G, but it's all both opposite direction, so I didn't really consider the plus minus sign. So with this function, we can easily get the T1. That is a 23.1 divided by 9.1 that lead to 2.34 seconds. Let's go to the from highest point to the building. So ball jumping from the highest point, which is the speed Vy dash is Vy2 is 0, and then the speed hit by here is Vy dash. So they lead to the same kind of the motion from the beginning. So it is Vy dash square minus Vy2 square equal to 2G theta H. But we get the number from this H in previously, and the information give the tall of the building, the height of the building. We can easily get the delta H, this number, which is 27 minus 15, 11.5, which lead to 15.5. And then lead to the Vy square, Vy dash square equal to 2 times 9.8 and then times 15.5 and square root of it. That lead to the number as of 17.4. So I think that's all for this question, and let's go over the solution with the questions over there. The first question is for the how much time does the ball spend in the air before landing the roof? And previously we get the T1 as a G over the Vy, which is 2.34, and T2 we can also easily get from the second simulation, which is Vy dash minus 0 divided by G equal to 7.4 divided by 9.8, that is 1.78. So in this problem, we can easily get the T equal to T1 plus T2 that lead to 2.34 and 1.7, so 4.72 here, or 4.12 here. And in the horizontally, as I talked about, because there's no acceleration, S equal to Vxt. Vx is the horizontal speed, and the T is the time spent on the in the air. So that lead to Vx, we got the 19.2, and then T is 4.1. So we can easily get some kind of sense. And then this is 976 and 79, 79 millimeter. And then with this information, the third question is for the what is ball's maximum height above the ground, which is this height, which we get the H as 27. And the fourth question for we take the ball to reach the maximum height, which is T1 equal to 2.34. And the last question for the velocity in the last velocity, the magnitude of the velocity. So we know about the Vy dash here and then the Bx here. So we can easily get the magnitude equal to square root of Vx squared plus Vy dash squared. And that is calculated by, let's say, 19.2 square plus Vy is 17.4 square. And after calculated, it's 26 meter per second. And the angle here is, as you can see, this is alpha and Vy dash, and this is Vx. So tangent alpha equal to Vy dash divided by Vx, which is 17.4 and 19.2. So alpha is arc tangent this number that lead to alpha equal to 42 degrees. I think that's all for this problem, this question. And in other video, I will go over the growth grid and how does growth grid working on this question. Thanks for watching this video, and let's go to the other video. Thanks a lot.